I don't know what to say. I really thank you. I know Dr. Maged since 2017, and trust me, when you meet him in person, he's very active, always smiling. I wish I can have the energy that he always has. Today presentation, let me share the presentation. Okay. Guys, before I start, I want to highlight actually 3 points. Today, in my presentation, I focus on 3 points. How to maximize, keep this in mind, the 3 points. How to maximize the land for agriculture, how to advance your electric system for agriculture, and at the end, how to reduce the cost of agriculture. Guys, what I'm gonna show you today, I'm not sure how well you are experienced into renewable energy, but have you heard of a building integrated photovoltaic, BIPV? Now, I am going to introduce to you a farming integrated photovoltaic system, which is, I believe it's a interesting and a new concept. So I hope you guys bear with me until I finish the presentation so you get the full picture. Before I start, I would like to tell you that our planet, it's not expanding. We are expanding, but our planet is still the same size. Actually, it's not the same size. When I read from time to time, I notice that you have more drought areas. Also, we have more area where they discover water. But you know, population is increasing. The planet had the same size. I wanted to share this slide to show you that a population is expected to reach 10 billion by 2050 from the current estimated 7.6 billion. Imagine what's going to happen to the food demand. What's the food demand for us? Where do we get our food? You need agriculture. You need either livestock, you need to plant farms, let's say potato, tomatoes, any type. This, where do we get it from? This is based on the United States population working on farm. Pay attention to this. In 1900, 10.9 workers worked in agriculture to serve 76 million people. So what's the percentage? The percentage of people that worked in agriculture is very high. Now we have 6.5 million workers in agriculture that need to feed 321 million Americans. So can you see the difference? Why we managed to reduce these numbers from 10 million? See, that percentage was about 15%. Drop down maybe to 1%, 2%, 2.5%, because of the advancement into technology, advancement into machinery, advancement into electricity generation, distribution, and transmission. That's why today we are focusing on the system from an electrical point of view. Why food security? It's very important to us. Economic development, sustainable living, human welfare. Especially now, we hear about COVID-19. A lot of people saying that we should eat organic food. We should eat more healthy food to build our immune system, to become stronger so we can defeat, we can challenge the virus. And I'm not sure what else coming after the COVID-19. So food security and energy security, water security, all this, it's picking up its momentum, strong momentum worldwide. Also, United Nations put one of its code is sustainable energy, sustainable welfare, healthy well-being, all this information. So from an electrical point of view, we need land availability with proper soiling for farming industry. Guys, irrespective what do you want to plant? You need land. If you want to have, for example, livestock, you need a land to put it. You need somewhere. So we need land availability with a proper soiling. We need sunlight. Guys, when you want to plant anything, you need a sunlight. And you need watering system. These three can be achieved. Of course, you cannot bring sun. You have to choose an area where there's a sun. But the sunlight that you need for the agriculture, for your industry, can be used to supply your electricity, and your electric system can be used at the same time to help protecting your areas. You will see how all this will come under stuff. I want to call it similar to building integrated agriculture, integrated photovoltaic system. During today's presentations, I want to explain to you guys. I'm not sure how well you are experienced into solar system. So I will quickly explain the sunlight role in what we're trying to do. Then I will explain the watering and how can we maximize the land availability for agriculture using our system. During today's presentations, I want to go through these items. I want you to have a full picture from looking at your pump all the way down to the maintenance commissioning of your system. I will go through step by step, and I will take more time into photovoltaic technology, photovoltaic system design, and how to achieve the connection diagram. This is, if you guys studied rotational machine, the power of the machine and the rotation of the machine depend on the frequency. So the frequency, the higher the frequency, the higher the rotation, because of the relation between the magnetic circuit and the magnetic circuit behavior and the electric circuit behavior. So this shows us that if we're running under the blue line, the frequency, the horsepower, and the torque changes depending on your voltage. That's why there is a stuff that you can set a minimum frequency, a maximum frequency for your system to achieve the optimum horsepower and torque required. To go into how can we achieve this? We achieve this by using a variable frequency drive. What's a variable frequency drive? It's an electronic circuit that controls the frequency of the supplied to the electric solar pump. Now, controlling the power required, current, this is the device I showed you. It's like a variable frequency drive. It's a very small, depending on the size of your machine, very small. I want to include this availability. What do you have available in the market? For you guys to have a better idea, the variable frequency drive that's available in the market can use single phase to three phase, can be three phase to three phase, DC to single phase, DC to three phase. That's where my photovoltaic play a role. So I use single phase to three phase, guys, just to give you more information. I use this if you have a single phase power source at home and you have water pump and you have any agricultural requirement, three phase, I use this variable frequency drive that has the ability to convert from single phase to three phase to operate the system. Because maybe to upgrade your electric system from a single phase to three phase could cost a lot of money. Three phase to three phase, I can use it, for example, if I have a heavy machine and I want to run it, the variable frequency drive will take the load step by step until reach 50 hertz or full load, which means if I'm using a generator, it will reduce the burden during startup. Now, DC to single phase and DC to three phase. That's where the advancement into technology, into solar technology, and the boom into power electronics allowed me to design a variable frequency drive that will take the photovoltaic output, convert it into variable frequency, either AC or DC, variable frequency, AC single phase, AC three phase, depending on my requirement, to my water pump. Now, before we go into the photovoltaic, where we're gonna spend most of our time, for those who didn't have much dealing with solar system, we have the silicon. We have monocrystalline, polycrystalline, PN junction. For those who do a little bit study about electronics, so these semiconductors have the ability to convert sunlight into DC current. So if you have sunlight directed to your photovoltaic cells, these cells generate DC current as an output. Every cell approximately, it will give you 0.6, 0.5 volt, depending on your system. Now, the most common material is the silicon PV panels. Guys, for your information, there's the most two commonly used is polycrystalline and monocrystalline. Are available into two currently. I don't want to go into the flexible one. I want to go into the two types, monofacial panel and bifacial panel. Keep this in mind, guys, monofacial panel and bifacial panel. Monofacial panel is designed to accept the light from one side. So the light will come only from one side. The other side will be blocked with a plastic or hard sheet. The bifacial panel allows you to capture the light from both sides of the panel, which makes it more attractive into numerous activities when it comes to solar system design. And you will see how this is the perfect solution for my agriculture electrical system design. What's a VFD and solar? Why they are now partnered together? They get married because of the agriculture requirement, and they get solidly bonded together because the solar panel output, it's a DC power. I need an inverter or a conversion between the DC to AC, so I can use it. Now, the VFD has the ability to convert the DC because of the transistors inside to AC. So instead of having an inverter, normal inverter, DC to AC, and then connect the system, I can use it straight away. The technology also allows me, or the technology of the solar panels have a fixed output voltage. Almost not, there's a small variation if you use a MPPT. My advice to you, if you go and wanna buy any device, make sure it has an MPPT. MPPT stands for maximum power point tracker. There is an algorithm, there's a circuit embedded inside your inverter or inside your VFD that will track the maximum solar system. I want to show you how, guys. Look, can you see this line in here? I'm gonna like this. Can you see what I wrote? Can you see my sketches? Guys, depending on what sort of voltage you are operating your system on, your current will change. So the maximum power point tracker will track the maximum power. How does it track the maximum power? It's equal VI, an algorithm. When this is flat, the derivative of my system, it's a flat, that's a maximum. Look, this is going down, this is going up. When it's get flat, your maximum power. So keep searching for the maximum power and introduce it to your system to make sure I always gain the maximum power. Pay attention. Look, irrespective, what's the sun radiation? What's a sun radiation? These are your sun radiations. We discussed before that the sunlight is the input fuel of your cell. Without the sunlight, I won't be able to generate. Depending on how much fuel I give my system, my output will increase. This is your sunlight, 1,000 watt per square meter, 700 watt per square meter, 500, 300, depending on your light intensity on the panel. The MPPT will track the maximum power point. Can you see the voltages almost aligned? Can you see that the voltages doesn't change much in a small deviation? And the power electronics allow me to have a window for my VFD. For example, my maximum power point operation for my VFD is between, let's say, 300 and 500 volt. Allows me to compensate for these small changes if required, for these small changes. I hope that's clear, guys. It's very important. If you guys use a pulse width modulation, you will have a losses could be reached up to 20%. You will lose up to 20%. So under, let me change a different color. Under max BMW, you could reach this power. So all this power is lost. So as an advice, whenever you want to buy any related power electronics device, hybrid inverter, grid connected inverter, VFD, any of them, make sure it has an MPPT, not PMW. Now, why VFD? It's very powerful with solar system. All I need is PV solar panels, variable frequency drive, and then I connect my pump. I don't need any grid to operate, which means I can use it into remote area, very far from the grid. Look, previously, let me talk previously. I want to talk in two areas. I spent 17 years in Sydney, and I was born in Lebanon, and I spent large percentage of my life in Lebanon. Sometimes in both countries, we want to invest in a perfectly located area where they believe there is a water underground. However, it's far away from the grid. To dig down and get water, you have to use a diesel generator, or you have to invest big money, large dollars, to take up the grid from its location all the way down to your site. This system, because doesn't need a grid, doesn't need electricity, wow, it's perfect for me. Also, it doesn't need energy storage, which means it reduces the cost dramatically, because energy storage is a problem, costs a lot of money. On top of that, doesn't have long warranty period. While the PV solar panels has a warranty between 15 to 25 years, the variable frequency drive between 2 to 10 years, depending where you want to get it from. The water pump, it's a water pump. You need it if you have a grid, or you have a diesel generator, or you have a solar system. So this will offer me a great advantages. Also, this variable frequency drive for solar system have the option to work in parallel with a generator and with the grid. So even if you have the grid and a generator, you still can use this in parallel with them. Now, this is an example. I just went and I picked up an example to show you every single system has a MPPT voltage requirement, and it will tell you DC power, rated power required. Also, I want you to focus on some of them single phase, some of them three phase. You have to be very, very careful which one you will get, single phase or a three phase, depending on your system. So the technologies allows me to choose with wide range of system. Now, during the presentation also, I will explain to you where did this come from. How do I choose my system to achieve the desired outcome? What does this mean? If I have a system and I have the voltages below 250 or over 400, my MPPT will not work properly, which means I am not harvesting the maximum solar energy and converting it into electricity, because I have a small error in my design. And it shouldn't be, this shouldn't exist unless there's a big mistake into my PV arrays design, or I don't have the sufficient experience to perform this task. Now, connect the panels to suit. That's what we discussed. This in here, the one that 250 and 400, is basically circuit one for us. Be careful about you connect the panels in series or in parallel. So I connect, these panels are in series. Should have used different color. These panels are in series, and the four are in parallel with the bottom four. So I can put the panels in series and parallel to suit my voltage and my input current. However, I want you to be very, very careful when you want to match two panels with different characteristics. Guys, two panels with different characteristics will give me a major problem for me, because of the voltage, the total voltage of them. Also, the current that's going to go through. Guys, this act like a current source, like a diode. I'm gonna give you an example like a water piping system. Guys, I have a pipe in here, and I put another smaller pipe, and then I put another smaller pipe. I have a water going into here. Guys, this water, when it reaches this end, it will cause a limitation. It will cause like a valve, close it down. I have 2 inches, goes down to 1, goes down to half inches. Same for here. In this system, I have the lowest one is 5 amperes. The whole system, this no longer 7, that's 5, that's no longer 8, that's 5, that's no longer 8, that's 5. Which means I have a massive losses because I have one panel doesn't match the rest of the panel's characteristics. That's one of the major issues if you are not aware or you don't have sufficient design. Guys, I've seen this in reality. I went and I inspected many installed systems, small system, I'm not talking about large systems, and I noticed that they use different type. Also, they use different type between poly and mono crystalline panels. They both react differently under temperature and under load. And remember, when I have an array in series, the current will follow the weakest current capability of your series. In here, like you have a fuse, a small gap, like a water, to reduce it from 8 to 5. So be careful about this when it comes to your design. Now, as we spoke before, solar system, the input of your solar system is sunlight. Same, when you buy a diesel generator, you need to go get diesel, put it in its tank and turn it on. I need to source the sun for my electricity. Look guys, the sun, if I live in the Middle East or the Gulf, this is the south. The sun moves from the east to the south with a tilt angle. So for example, this is the south, this is the sun goes down. This is my sun. It's very critical for me to make sure that I study where my location. If my location in Sydney, this south suddenly become north in Sydney, because I'm on the other side of the planet, and that's where my sun shine, toward the north, not the south. So it's a very critical for me to design my system to suit the location. Also, that's facing south. When you're facing south for our part of the planet, the sunlight will rise in the morning. The sunlight will rise in the morning. Guys, you know, when the sunlight comes up, we have two things. This is my solar panels. I have an angle with the ground. When the sunlight goes up, I don't have direct sunlight to it. I have two issues. Number one is my sunlight not directed into my solar panels. And on top of that, the sunlight in the morning, it's weak, very weak. That's why the power goes up and to reach maximum in the midday period and then start diving down. Start diving down until sunset. So I have a challenge. I have a challenge as a PV solar system designer. For example, if I have a 50 kilowatt or 500 kilowatt, if I have a 500 kilowatt pump, I cannot use this system. Why? Because I only reach 500 for a small period. Maybe this system is good for a 350 pump. Will allow me with the VFD, by the way, with the VFD will allow me to start working here and stop working here. We're gonna explain it how. So it's very important to understand the shape of my output. So if it's south, my output power concentrates midday. If I have a water pump, I need to understand the water pump sizing, because I cannot use only the peak. I have to use somewhere in here to allow me for a maximum or wider operating hours. Guys, if it's facing east, if I have my panels standing up and facing east, I will have, this is the morning, this is, for example, 7 a.m. I will have my power goes up like this, because the maximum now will be located around 10 a.m. Because if my panel oriented toward the east, in the afternoon, midday or afternoon, I will have no more sunlight directed toward my panels. So what I did the comparison between 500 vertical facing east, 500 kilowatt vertical facing west, and the output power of your standard. The black one is your output power of your standard, this one, of your standard. Now, this is my peak and this is my peak. So depending on my orientation and the tilt of my panels, my output will be affected dramatically. For the monobifacial, guys, please pay attention. For the red one, for the monobifacial, I need 1,000 kilowatt panels. For the monobifacial, for the monofacial, I need 1,000 kilowatt. For the bifacial, I need, for the red one, I need 500 kilowatt or 500 kilowatt. That's why the bifacial panel gave us a great improvement. So for monofacial, I need to double my panels. For the bifacial, under this condition, I need half the panels under this condition. Now, look guys, I need to now understand where's my working zone? Is my working zone now, is it being extended to here if I go to that far? Or I want to stick to this working zone? And I need to understand what can I do with this one and what can I do with the black one? I need to understand how can I advance my project with this data. Now, I end up running multiple simulations to show you if I have a load as a black one, under the black one I have, this is my desired load. This is my desired load. Guys, sometimes I have a load structure. It will show you that the red, see the red items, these ones, offer you better solution than the standard south. If I have a blue, this is my south oriented standard panel. All this area, guys, I'm gonna highlight, I cannot operate my system. All these areas that I'm crossing like this, my system will not be operated because there's a huge gap between my load and my generation. Guys, my load is the black one, my generation under south is the blue one. When I combine east and west system, I'll suddenly have a red. Under red output, I have only this area I will lose power for. This small area, the small areas, guys, I can compensate with VFD. The VFD, for example, if you have a 100 kilowatt pump and there is an 80 kilowatt or a 70 kilowatt output, the VFD will allow your pump to run at a 70% of its capacity. So you still have water out. 70%. If you have 80 kilowatt, you have 80%. 90 kilowatt output, you have 90% of your pump capacity. So small system, you'll compensate. However, when you have a big system like this, you might not be able to run your pump. So it's a very critical, very critical to make sure that your system design meet your profile. If you want power in the morning or you want power in the afternoon for your farm, for your agriculture purpose, you need to make sure you design the PV solar system to generate the power required at the hours you required. Now, new promising technology, the bifacial. Bifacial for agricultural purpose offers vertical arrangements, reduce the impact on the ground disturbance, you will see how, increase the morning and evening production without additional panels. When I have monofacial panel, I need two panels because the back of your panel for the monofacial, it's a blocked, has a sheet, a black sheet, plastic cover. For the bifacial, have tempered glass both sides, which means will allow me to harvest the sun from both sides of the panels. Guys, it's the same silicon. The same silicon. Instead, after the EVA sheet, instead of having a black or a plastic cover, now I remove it and I put a glass. It's a smart way to increase the system. In Dubai, we did a research in 2019, I believe so, where we showed under the desert condition, we have an increase, even if you put it the same way, the same tilt and layout, you have an increase by 20% if you use the bifacial over monofacial. For our agriculture, you will see the massive advantage. Look, guys, this is into desert system. This, I want to go to Mohammed bin Rashid Solar Park. You will see that the backside will offer maybe 20 or 30%. Guys, the structure is already there. The panel is already there. All you have to do is buy bifacial panel and connect them in a proper way. The backside, guys, will reduce the soiling impact. There's no more dust will stick on the back, will it? No. So under soiling impact for the desert, you might lose 20-30% of your panels. You will generate it back from the backside without doing anything. That's why the bifacial system offers a great, this is in reality. This is an animated system that's in reality. You can see that we haven't done much. All we've done, we were smart by putting another glass, tempered glass at the back instead of sheet. Now I need to make sure that when I connect, I don't break the glass. That's it. I need to be smart when I connect it. And depending on your location, the ground could be very reflective. And when the ground is very reflective, this power that goes on the sunlight will increase, which increases maybe up to 40% your production for the same setup. When you're looking at 40% additional production for the same setup by just changing the design of your panels, it's very worth it. Imagine you're talking about 100 megawatt and someone tell you not 40 megawatt, an extra 20 megawatt, an extra 30 megawatt. Guys, per hour, because this, depending on the sun, it will generate a massive additional power, the bifacial. Now, this is the bifacial. That's how it works now. This is based on the research that we did, and it shows that it does increase by 20 to 40%. I want to go to the agriculture. Guys, before we go, this setup required land, required to occupy land. Correct? Required to occupy land. Now, for agriculture, we spoke about land availability. It's very important for me. The bifacial panel allows me for vertical arrangements because it can harvest the sun. When the sun goes up from the east, goes up like this. This is my sun goes up. In the morning, it will harvest this. In the afternoon, see this. Also, look. So, depend where the sun is. The only time it doesn't harvest is midday when it's like this. However, there will always be a reflection from the ground. There will always be reflection from the ground. So what I've done for my bifacial is I reduced the number of panels for a vertical arrangement. I managed to have all this ground for me to use. At the same time, you will see now the increase in power that you want. This is a reality. This is a reality. Look, I can now plant whatever I want. Guys, this, I can put in whatever I want. Let's look at it from a fencing perspective. You want to have a fence? You can put fence. Some people say that people throw rocks on it to break it. They can throw rocks even if it's a horizontal, even if it's a tilted by 20 degree. I don't want to go into this discussion that it can be damaged. Now, all this area can be farmed. However, if I haven't connected like this in a tilted angle with 20 degree, it's very hard for me to actually utilize the land under it, unless I want to raise the structures very high for my machinery to go inside. This system, you will see now the advantages from an electrical point of view. I think it's clear to everyone that this system will offer us a more productive land, way more. And the other thing, soiling the dust residue on the panels actually reduces the energy up to 40% if you don't wash it. When it's vertical, it's not gonna stick on it. It doesn't stick. If you have one tilted at a 20 degree, the dust residue in here, it will stick. However, under vertical, it's very, very hard for the particle to stick and be thick to eliminate or to reduce the sunlight into the panel. And by the way, guys, this was done when I was in Dubai. We actually physically tested this from a dust perspective. And I have pictures, and you will see it's a big difference between these two systems. Now, this is the output of your vertical bifacial. I installed a vertical bifacial, and this is the output for April, May, June, July, August, September. Why I choose these months? Because I can add actually October, because November, December, January, February, March, even part of April, we have a rainy season. So it will be, we rely on the water pump very rarely when it comes to agriculture. A lot of people actually design dam that will harvest the water on top, and actually it's raining, you don't need it. Now, even if you need it, you still can harvest power, but because of the rainy season, you have no cloud. You have a cloud, you have no sun. So your power will be reduced dramatically. However, it's raining, so you don't need a power. You don't need water to water your, for example, your potatoes or your eggplant, anything that you plant, it will be watered normally. Now, this is my case study that I want to share with you guys. 60 horsepower, 3-phase water pump to support a potato growing farm. In this system, I have no grid. The electrical requirement for my system is 45 kilowatt. Because of what I did show you before, that the solar goes up like this, I cannot use a system that gives me 45. It doesn't work. I need 45 to be somewhere in here. Common practice to use 150% or 180% of your capacity. So use 150%, 160% of your capacity. So the system that we designed now is 74 kilowatt solar panels. We did the design for a standard system, and then we did the design for vertical bifacial to show how things can change between vertical bifacial or facing south standard arrangement monofacial panel. Remember, this is a critical system, guys, that for a irrigation system, for a solar system, you cannot use, if you have a 45 kilowatt, if you use a 50 kilowatt solar panels, your pump will not work under full capacity for more than small period of time, which then your client will be unhappy at all, because he or she paid money to have 8, 9 hours, 7 hours worth of water under full capacity, not 1 hour under full capacity and the rest under reduced capacity. This is the output that we found. This is for 30th April. We didn't go into summer. We went into the break of spring. We chose a date, and then this is the output when you have a standard PV monofacial facing south. This is the pump operating. I didn't take into consideration anything below 80%. So under this system, I have 1, 2, 3, 4, 5, 6 hours. The pump is working under full capacity, and 2 hours under 80 to 90%. When I used 74 kilowatt bifacial panel, so I use the same number of panels. However, now these panels are bifacial. I end up with, this is the output. And now I have 1, 2, 3, 4, 5, 6, 7 hours of 100% capacity. Guys, notice one thing. I can now operate the system early morning and then evening. It's healthier for the farming industry. Midday, during this period, midday, the ground could be very hot. If you give water, depending on your plant, you could burn the root of your plants. So irrespective of all this, I'm not a specialist. I have no information whatsoever regarding the agriculture food, how to plant it properly. But I look at it from an electrical point of view. I have now 7 hours of full capacity, 2 hours 90 to 95, 1 at 98%. On the other hand, I have 6 hours in here. I have 2 hours 80 to 90%. So clearly, the bifacial panel for agriculture increase the same number of panels, increase the number of operation and the full capacity, increase the number beyond 90% of capacity, while the standard monofacial allow for 6 hours, which is reduced by 1 hour in feeding. And on top of that, this will take additional ground. Will take an additional ground for your system. So it's very critical to keep this in mind. What's a cost analysis? Look, guys, I wanna clarify one thing. I've been in this industry since 2007. Between Indonesia, Thailand, China, Europe, Dubai, Beirut. This panel cost is based on if you directly import this good from overseas. So if you go to Canadian Solar and you tell them, I need this panel, or you go to China, the monofacial panel price start at 0.25 per watt. Every panel, same like a car, every panel depending on the cell that it's being made of. You could use 5BB, you could use AA, you could use different types. You can use poly, mono, crystalline. The cost will change. Also, the thickness of your aluminium ring. Is it 30 millimeters, 45 millimeters? All this will add to the cost. The thickness of your glass. All this will add cost to your panel. Bifacial panel, also depending on the manufacturer, will start by around 30 cents per watt. FD cost, depending on the brand and price, for let's say for 50 kilowatt. If you want to go to a Chinese manufacturing or Hong Kong, maybe you can source it for 1,500, 1,600, you import it for 2,200, 3,000. If you go to ABB, maybe 7,000, 8,000, to Schneider, depending on your budget. Infrastructure and wiring, depending on the location. Is the location clearly to access? Is it near your water pumping, near your electricity? So all this will add to your cost. However, for my panel system, look at the cost. If I use, there's only $3,000 difference. $3,000 difference. VFD the same, because I'm using the same number of watt. Infrastructure, I can argue that bifacial has lower cost because I will show you why. I can use an existing infrastructure to install it vertically because every farm has a fence. Need to protect it. So the foundation of the fence already there. So it's a bit cheaper. Also, you run it along the fence, the wires is more safer than run it in the field or put it between. When you have this verticals, you have to run it in a channel. So it's more expensive, I can argue, monofacial than bifacial installation. Now, these are the cost of the systems. The only difference in cost will be the panel. Bifacial system under my conditions offer you another additional 500 square meters of land for agriculture purpose. Will offer you an additional 500 square meters for land. By the way, guys, this is a 45 kilowatt. That's a small farm. You're talking about big farm. You're talking about maybe 500 kilowatt. You're talking about 1 megawatt. I'm talking now into small farms. So 500, this from a plastic housing perspective, from a different perspective, it's a great. No. Reduce the risk of power losses due to dust and other residue. That's very critical. Cleaning the solar panels, I'm telling you, I have solar panels in my house. To cleaning, even if every 2 months, take a lot of effort. Now, VFD, if I have a diesel system, I don't need to get rid of it because all variable frequency drive allow the connection of a grid or generator to the VFD. So for example, if one day you don't have PV solar system, you don't have sun, you can rely on this to support your pumping system. So it will offer also this small device, reduce the burden on the generator under startup current. If your pump doesn't have a soft starter at the beginning of it. Now I want to go into mechanical protections. Guys, we have heavy machinery. It's being used into agriculture, same into industry, same everywhere. And some location could be crowded with machinery. So I don't want to go locate my system at this point. Irrespective if it's a vertical or if it's a tilted, I have a high risk of a damage. So what I do is I need to locate it somewhere else. Under this condition, maybe the bifacial, it's more, the risk it's higher, unless you raise it up above the system. You have to make sure the system is located in an area to maintain the followings. You have to make sure the inverter is located into an easy accessible locations. You don't want to, every time you want to access your inverters or a VFD, you shouldn't go through an obstacle. Inverter locations must be protected from machinery movements. So if you have inside your agriculture, you have a warehouse, please don't put it where you park your tractor. You park other machinery, unless you protect it. Because if you lose it, if you lose 1 panel, 2 panels, 3 panels, 10 panels, your system still works. If you lose this one, you're gone. You want to go buy a new one until you order it, comes to you, or then you have maybe to pay 3 or 4 times more. DC and AC cable must be protected. That's a common practice. Every country set a strict regulations for DC and AC. I want to tell you one thing, guys. DC eats steels, eat it. So you have to be very careful about DC. You cannot let it touch your DC. Electrical protections. You have to make sure the DC circuit breaker is sized accordingly to the PV requirements. You have to make sure that the AC circuit breaker suits the inverter requirement. You want to put the AC circuit breaker to protect, not to damage the inverter if it's too large. So be careful about this. RCD might be required depending on your location. RCD, it's a residual current device that will allow for 30 or 10 milliamps to go through before tripped. This is for human safety. So it's a very critical to make sure. Earthing system installation is required, especially when I have a farm that have it horizontally, because it will cover a large area. And of course, I need to study the ground flash density when it comes to lightning purpose. Lightning surge arrestor to be installed at the inverter to suit your system. That's very important. Of course, your location will determine the earthing and the lightning system requirement. This step for commissioning must be followed. Must be followed so you doesn't cause damage to the equipment, no damage to yourself. All required protection are installed and tested properly. Ensure the inverter is mounted as per the manufacturer manual. Guys, some inverters need to be vertically, some of them horizontally, some of them has a breathing requirement to breathe so it doesn't get heated and then blow. So it must be followed. Coloring, guys, you have a positive, negative now. You have line, you have earth, you have neutral. Please make sure you follow your country requirement standard for. Make sure all disconnectors are in off position during final checkout. Make sure everything is isolated when you check it. Do some testing to make sure that on the other side of your disconnector, where it said it's off, you don't have power. Test before you touch always. Test the DC terminal of the PV connection to verify the expected voltage. Why the expected voltage? Because I don't want to give more voltage to my VFD or my inverter, otherwise we'll get damaged. Also, I can test it under MPPT condition to make sure it's working. Check the polarity between positive and negative. Check the grid terminal. If you have a grid, check the line-to-line voltage. Guys, I cannot connect 230 volt to 120. I have to be careful. I have to connect properly. If I have an inverter that comes from the state, give me 120 single phase, I'm not going to connect it to 230 single phase in the Middle East. Make sure the grid terminal voltage match the inverter data. Some inverters require login user interface. If applicable inside your setting, please not just connect it, turn around and go. You have to check all this. Establish the connection between the inverter and the grid. Check the inverter reading. Verify the reading with the inverter manually. That's if you have a grid. You don't want to damage it. Establish the DC connection to the inverter. Some inverters require a special startup. Not all of them the same. You connect and you move on. Most inverters have an internal delay to check the grid and sync if there is a grid. Maintenance. PV system has low maintenance. However, for mechanical, when you have weather condition, could have rusted system, under movement, your bolted system could get loose. So please complete your check. Check the panel for dust and soil residue because that's the killing for your output. Perform a cleaning as required. Check electric connection to make no loose. Remember, you could be running wires for 200 meters, 300 meters, 1,000 meters. Loose wires under the connections. These are some pictures. It's not working, why? One second, let me just see why this slides. This is the project that we installed to show you the setup. One second. This, I don't know why the first one is not working. I will check it later. This is an example of, this is for a 55 kilowatt system. It's not, it's 130 panels. This is a standard arrangement. This arrangement, it's covered the pathway for your system. Imagine all this. Sorry, go back. Imagine all this have a bifacial opportunity. You can see the light at the back, how it will increase. Look, this is a farm or a house or whatever you want to see it. All this infrastructure already there. All this infrastructure already there. All you do, instead of having it on a 2.4 meters apart, now your requirement is 2 meters. You run the wires, it's safer than running it somewhere else. That's why it's called agriculture integrated photovoltaic system, because now it will give you an opportunity to integrate into the system. Why this is... Look at this. I don't know why this is. Look at these ones. This as well. This is could be for a animals farming system. You know, you put it across the animals. Look at this one. Guys, you can raise this, the system in here can be raised to the height that you want. If you're too concerned that this might damage it. Look at this system. In here, I can use whatever I want to plant into this location, and so on. So it will help increase. I want to go back to the first, to this. I want to show you. Let me get rid of this one. This system is for 3 kilowatt. This system is for a 3 horsepower, 3 horsepower water pump. The cost of the material, $1,800. And the person will have about 8 hours of water every day, maybe for 6-7 months, few hours for the rest of the months of the year. The cost of this system, it's about $15,000. So the cost of it, it's not much. However, if you want to go and engage a big consultant, big company, maybe the cost will change a little bit because they have a higher overhead. However, the cost of this type of equipment these days, it dropped big time. Before, it was 120 watt or 80 watt, you buy it for $200, $160. Now, 400 watt, you buy it for the same price as what I used to buy the 100 or the 80 watt system. Now, I will end my presentation now. Thank you for listening, and I open the floor for discussion and questions. I can stop sharing. Okay, guys, any questions we have or any discussions?
Dr. Ahmad, can you, if there is any questions in the chat box, can you moderate please the questions?
Yes, Dr. Majid. Good evening, everyone. Thank you for attending. Thank you also to Dr. Muhammad for this very interesting presentation, very useful. We have some questions that we gathered during the presentation, and I will start with a question came that, can we use mirror to get the sun in the midday?
Yes, I want to show you one thing we did in Dubai. Remember, this is focused on agriculture, but I want to show you one thing. Let me share my screen again. I will share this one, and I write on one of the empty pages. Look, what we did in Dubai, we can have a wall. Come on, why this is? We can have a wall on this ground. We can paint. This is, you put it vertically on the roof. You can paint this as a reflective material. You don't even have to have a mirrors. You can paint it, and of course, this, when the sun goes up like this, it will reflect. So you will increase the input of it, of course. But this, what we did, is for agriculture purposes. You don't want to go paint the ground. You want to plant the ground. However, this will be perfect if you want to use it for a highway. Let's say I have a highway road. I put my vertical panels in here. And the highway shouldn't be mirrors, should be some sort of material that doesn't absorb the sunlight, that reflect it. Also, you have to take into consideration the safety of the drivers to increase it. There is a lot of opportunity for it, but for this presentation, I kept it purely to a farming, animals farming purpose. The one I showed you in here, this could be for farming purposes. This, all of it for farming purposes. There's nothing stopping us from having it for animals point of view, like these people. You're concerned about this, you can raise it a little bit up. This as well, it could be a racing track for horses. Could be a lot of things that you can establish. Does that answer your question?
Yeah, thank you. Thanks. Coming now to a question from Dr. Majid about the bifacial panels. For the bifacial panels, what about the cost and RPI? Also, life cycle to change the panels due to less efficiency and maintenance purposes, maintenance cost and ROI, rate on investment.
Okay.
The
cost of the system is just the cost of the panel. It's just the cost of the panel and nothing else in regard to this from a point of view. Let me just go back. Let me go back to the panels. Any panels have silicon, has an EVA sheet, has a tempered glass. On the other side, they put an EVA sheet and they put a black. Instead of this black, they remove the black and they put a tempered glass, same as this one. So the cost is depending on the manufacturing. If I go and I buy one container from them, the price will be different if you buy 20 containers, 100 containers. So the cost of it could increase 30%, 20%, 50%, depending on the quantity and the deal that you have with them. But currently, if you go to, very easy, go to Alibaba, you will see that the cost of, in China, for a monofacial, it's about 21, 22 cents per watt. The other one could reach 27, could reach 31 cents per watt. So depend on the quantity. They will tell you minimum quantity. They will tell you exactly. Now, from an efficiency perspective, it's the same. There's no difference. Efficiency, it would increase because if you install it this way, vertically, with an angle of alpha of 20 degrees, this proved you have an increase between 20 to 40% of an output because of this and the incline that goes up. And remember, this is very critical to get. When you have a solar farm, you have, these are your solar panels. So you have, I don't know if you guys can see the yellow ones, you have the sun. When the sun goes like this, it reflects. Go to Muhammad MBR in Dubai, you'll see the massive of it. Go to any solar farm in Sydney and you will see the difference.
Okay. Thank you, Doctor. Another question about bifacial panels and operation. When you show in one of the slides the parallel lines, so what is the maximum separation between the bifacial panels to operate efficiently?
Okay, I'm gonna answer this question. Remember, you're working into farming system. Now, this is your sunlight. Use different than yellow. Now, there is a software that will allow you. This is your ground. This is the sunlight incident. For example, this is 5 degrees at 6 a.m. For example, 6 a.m. in the morning. Okay. So if my solar panels is sitting in here, I need to make sure that the second one, I do the quick calculation to be like this. away from it. So I need to make sure that this is my solar panel. That's the first one. That's the second one. This distance depends on the sun location. Now this, I can use this. So now this will work on an earlier system. So depending on what time I want a full capacity, I want zero overlap. I want zero overlap between when the sun, remember this is the east, the sun goes up like this. If I want it at 5 a.m., maybe it's going to be too large, depending on where do you live. If I want it at 6 a.m., that's fine. You could separate it by 10 meters, 15 meters, depending how high as well you want to take it. You want to take this, for example, 0.5 meters, and then you put 2 meters, or you want to raise it 1.5, and then you put this on top of it. So all this play a role in determining it. However, for my farming purpose, I have a farm. I never seen a farm that goes for 10 meters. You know, I have a wide farm, could be 40 meters, 30 meters, 20 meters. That's more than sufficient. Also, I can play it differently. The panels, it's like this. Instead of putting it vertically, I can put it like this and take more. If I have a narrow land, but longer, I can put it sideways to reduce height of it.
Okay. Thank you, Doctor.
Yeah.
Thanks. Another question from Mr. Osama saying, how can the power stabilize without batteries?
Okay. Why question is, the motor control work on V over F, voltage and frequency. The VFD technology will stabilize, work with the voltage and frequency for a control. If you go read if you want to buy a VFD, check the control mechanism. So the voltage always stabilize based on the power. Because if I have, for example, 100 kilowatt pump, this is my pump system. And then I have only from the sun, I have 80 kilowatt from the sun.
Yeah.
VFD will adjust the frequency and everything, the control system, to make sure that this now will work on a 80%, which means now it's could be working on a 45 hertz instead of 50 hertz. That's how it stabilizes it. Check any data sheet, any catalog for a solar VFD, and we'll tell you the control mechanism, how they make it stabilize the power.
Okay. Another question, I think also from Mr. Osama, about the life cycle. What is the life cycle of this solar cell?
Life cycle, like I said before, it's 15 to 25 years. Some people argue the fact that after 15 years start derating, some of them. Now, I don't think there is any equipment that they can buy that will give them 15 years warranty. Any generator, anything. So when it comes to me, when someone tells me this panel has between 15 to 25 life cycle, I think it's sufficient. Because if you want to do any project, you will design your system or your return on investment for 3 to 5 years. No one's going to design it for 15 years return on investment. So the life cycle of these cells around 15 to 25 years, depending on the manufacturing, depending on the solar radiation, humidity, heating, a lot of other factors.
Thank you. There is a question from Mr. Mahmoud. Actually, I couldn't fully understand it, but I will just repeat it for you, just for your answer. He said, can we use vertically PV-like level if we have more than a layer, like row number 1 for 2 meters from 2 sides and in the middle 4 meters? Maybe this is not
So I'm not sure if I get it right. So you have a wall like
I
this.
also couldn't understand it, but
You will
let
put
me-
one like this. This is facing this way. Then he put one like this facing this way.
No. Hi. I mean, if we have a lot of layers, maybe it's 3 row, okay? And
Okay.
in the middle, the higher one. And from two sides around, it's 2 meter and 2 meter. This is what I mean.
But this the
Yeah,
problem is.
like this
The
one.
problem is the sun. This is the east.
Yeah.
So when the sun goes up, this will get,
Ah.
this will be blocked.
Blocked on this. Yeah, it's
Yes.
right. Yes, thank you.
You're welcome.
Thank you. I think now we are done with the questions. We don't have more questions for this. Anyone have any question, please? More questions on this subject? Imagine no more questions.
Okay. I think if there is no more questions, I think if you had been seeing also Dr. Muhammad into the slide, his communication details, I would recommend you. I see one from Dr. Osama about the VFD and why we are just addressing it about agriculture. Yeah, today is Dr. Osama's, we are addressing the topic. It's about managing electrical system on agriculture field. However, it's Dr. Muhammad, his expertise, as we mentioned earlier, and he was in Dubai earlier, he's working in full structures, buildings, power stations, name it. So it's like, so that technology can be used actually in every different construction, in all the full segment of construction. It can be already used, the technology. I think it's, again, it's like, someone has been addressed me, actually is like 2 weeks back, is a consultant in Dubai, and he was mentioning for me that he have a person, he building his villa, and he have his yard, and he want just to keep some panels there in the yard, is to be covering, it's like a partial of his already grid, to reduce down, you know, the expenses of the electricity coming from the main grid, but he wanted in a certain way that return of investment, it should be faster. And I just address him and I tell him, okay, yeah, that is, you can maybe communicate with Dr. Muhammad into that field, which type of solar, which type of panel, which type of battery, which can be give you in a quick response is what is the return of investment. However, we need to understand when we're working with PV panels, we talk about assets, and assets, we talk about life cycle. So we need to think about long run, not only today, how much it will be already costing. Sometimes it looks big today, but in 3-4 years, you return actually all your initial capital investment and starting your benefits actually on it. So again, if anyone you have specialized questions about the solar, about solar in construction and housing and towers, I remember Dr. Muhammad, he earlier presented for us a very, very attractive presentation about how we can today in the facade can be different colors. So we can have actually in the, again, in vertically in the all the buildings, and instead we have a normal facade, we can have it already a solar. Now the full building, it will be now generating power. I mean, it's like it's actually it should be there. It should be used now. Why we are trying to look for energy efficiency when we have things we can utilize and we can optimize.
Guys,
yeah.
Can I add to this, to Doctor? See the wasted power. You can connect it to a dynamo that will, then you can run your diesel generator without diesel. There's a lot of technology that's been evolved. And like I said, in the VFD, you can use it any type of motor. Elevators, you can use it into any factory that have motor, conveyors, anything. But this, we focus on the agriculture for water irrigation to show you that if you use the new technology, the cost associated, it's not that huge. You can blend it into an existing fencing infrastructure, into other infrastructure. By the way, you can use it. If you have a heavy wind area with a proper structure, you can protect your plantation, for example, whatever you plant. There is a lot of advantages to it. Now, there is an additional cost. I agree for the panel. However, if you incorporate the panel with an existing infrastructure, you compensate for the cost, you get more power. Also, don't look at it from a small point of view. If you have a massive project, 500 kilowatt, 1 megawatt, when someone tells you, irrespective, if you put it this way or you put it vertical, if someone tells you you will get an extra 20%, that's a 200 kilowatt for just buying this type of panel. Exactly the same setup, same panel, same inverter, same everything. Imagine how much extra money, if you are connected to the grid, how much extra money you can give, how much extra power you can give to the grid, and how much you can get paid for it, for the same power setup. So solar system, it's getting very advanced. Now we have the capability to do a hybrid system with diesel, solar, wind, and a grid. I have it installed here. I have a solar system, I have a wind system, and I have the grid. They 3 into 1. When I don't have solar, I have a wind. If I don't have both of them, I have the grid to support. It's a very advanced and sophisticated technology these days. The presence of electric vehicle that's coming up, trust me guys, it offers a free energy storage, free trading. It's a massive a new domain. But like Dr. Maged said, this presentation focused on agriculture purpose only.
Thank you very much, Dr. Muhammad.